In this video, we are going to be discussing on Part B of the West African Senior School Certificate Examination Chemistry Paper 2. That is essay. We will be starting with November 2000, question number 1 and 2. But before we continue, I want to thank those of you who have taken your time to subscribe to my channel. For those of you who haven't subscribed to this channel, please like the video, share to other learners, especially those who will be writing this academic year, and most importantly, take some time and subscribe to the channel so that other papers that we are going to be solving, you will be the one to receive them first. Thank you for taking your time to subscribe to my channel. Let's get started. Part B. Answer 4 questions in all. 3 from section 1 and 1 from section 2. All questions carry equal marks. Section 1. Answer 3 questions from this section. Question number 1. A1. List 3 characteristics property of transition metals. List 3 characteristic properties of transition metals. Before we proceed, you should know that not all the D block metals or D block elements are transition metals. So the elements that are transition metals, they are unique. Not all of them that are in the D block are considered as transition metals. That is why the transition metals have unique characteristics. So starting with A1, list 3 characteristic properties of transition metals. The 3 characteristic properties of transition metals. Characteristic properties of transition metals. There are 3, but I have given you more than 3 so that you can select. The first one is that transition metals or transition elements, transition metals or transition elements, they form complex ions. 2, they form colored compounds. 3, they have variable oxidation states. 4, they behave as catalysts. They have catalytic property. They have catalytic properties. 5, they are good conductor of electricity and heat. And above all, number 6, they are hard and rigid and are used for construction. So these, if you name any 3 from these, then you will have your marks. A2, which of the following metals belong to the first transition series? Which of the following metals belong to the first transition series? We have chromium, we have lead, we have iron, we have magnesium, we have aluminum, we have magnesium. We have manganese. Chromium, lead, iron, magnesium, aluminum, and manganese. So which of them belong to the first transition series? The ones that belong to the first transition series are chromium, iron, and manganese. Question number, the second, B. Copy and complete the following table. Copy and complete the following table. The table is divided into 3 columns. The first column is the alloy. The second column is constituent elements. And the third column is one major use of the alloy. So now, the first alloy is bronze. The first alloy is bronze. Constituent element. Which are the elements that make up bronze, or which are the elements that are used in making bronze? We have copper and we have tin. Copper and tin are the constituent elements of bronze. Now, we go to one major use of bronze. One major use of bronze is it is used for the manufacture of coins. The coins we use for our daily financial activities. Coins, they are used for the manufacture of coins, and they are also used for the manufacture of automobile parts. The second alloy is steel. What are the constituent elements of steel? Steel is made up of iron and carbon. Iron and carbon. That's what make up steel. And one major use, I will always give more than 2 uses for you to select only just one. One major use of steel. I have given you about three of them. Steel is used for construction. It is also used for household appliances. The household appliances, they are used for it. It is also used for the manufacture of weapons. It is also used for the manufacture of weapons. Again, once more, steel is used for the manufacture of weapons, for construction, and for household appliances. Okay, the next alloy is duralumin. Duralumin. Duralumin constitute or is made up of copper, manganese, and magnesium. What is duralumin? Duralumin is an alloy of aluminium. Duralumin is an alloy of aluminium. So we can now say the major elements that constitute duralumin are copper, manganese, and magnesium. Copper, manganese, and magnesium. Now, what is duralumin used for? One can say one major use of duralumin. One major use of this is it is used for the making wires. It's used for making wires. It's used for making bars. It's used for making rods, especially rods that are used for screw machines. Rods used for screw machines. Okay, that's all. Let's go to question number 1C. 1C. A razor blade of mass 5 gram required 50 cm cube of 2.0 mole per dm cube hydrochloric acid to react completely, according to the equation below. Once more, a razor blade of mass 5.00 gram required 50.0 cm cube of 2 mole per dm cube hydrochloric acid to react completely, according to the equation below. In the equation, we have iron, solid plus dilute hydrochloric acid to give us iron 2 chloride and hydrogen gas that is being released. Based on this, question C1, calculate the mass of iron in the blade. calculate the mass of iron in the blade. And C2, state two ways by which the reaction time can be reduced, assuming the blade retains its form at the start of the reaction. Let's start with Roman 1, C1. Calculate the mass of iron in the blade. We have been given the relative molecular mass, or the relative atomic mass of iron to be 56. That is 56 grams per mole. Okay, C1. Yeah, the first important thing, this is a stoichiometric type of a stoichiometric problem. We have to write a balanced equation. Good thing the balanced equation has been given. Iron plus dilute hydrochloric acid to give us iron 2 chloride plus a hydrogen gas that is being released. From the equation, we are calculating the mass of iron in the blade. That is the main thing. We are calculating the mass of iron in the blade. So the first thing here is that, before we continue, please, I want to tell you that when you have a problem like this one, when an equation has been given, please make use of the equation. The examiner is not a foolish. The examiner knows why they have given the equation. They know that the equation is very, very important. This is stoichiometry. The equation is very, very important in solving in solving the problem. So make use of the equation and also make use of the relative atomic mass that you have been given. Remember, we are calculating the mass of iron in the blade. Okay, let's continue. After having written the balanced equation, from the equation, you will see that 1 mole of iron is reacting with 2 moles of hydrochloric acid to produce 1 mole of iron 2 chloride and 1 mole of hydrogen gas that is being released. From this equation, we can say if one mole of iron will require 2 moles, will require 2 moles of hydrochloric acid. A 1 mole of iron will require 2 moles of hydrochloric acid. Then how many moles of iron will require 0.1 mole of hydrochloric acid? Why do I say 0.1 mole of hydrochloric acid? Remember, you were given hydrochloric acid. The information given in your question is very, very important. The information given in your question is very, very important. You were given 50 cm cube of, that is the volume of hydrochloric acid. You were also given the concentration of hydrochloric acid, you were given the volume of hydrochloric acid as 50 cm cube, and you were given the concentration. Make use of this in knowing the number of moles of hydrochloric acid. To have the number of moles of hydrochloric acid, you know that we are told there is a formula. We say concentration equals to mole divided by volume all over volume in dm cube. We will need to convert this 50 cm cube into dm cube. We will need to convert this into dm cube, so that our moles, rearranging the equation, our moles will not be what? Our mole will be the concentration times the volume in dm cube. So just as I've just mentioned here, please look at it. The volume of hydrochloric acid is 50, and in 50 cm cube. Then in dm cube, it is 0.05 dm cube. So the concentration is 2 mole per dm cube. Now, we are told that moles, rearranging the equation, moles will now be equal to what? Concentration times the volume in dm cube, which will be 2. The concentration is 2, which is 2 times 0.05. And the number of moles of hydrochloric acid involved, or dilute hydrochloric acid involved in that reaction, will be what? 0.1. Therefore, Using this equation, we can say if 1 mole of iron requires 2 moles of hydrochloric acid, then how many moles of iron will require 0.1 mole of hydrochloric acid? Solving the number of moles of iron, we will have 0.05 moles of iron. That is step number 1. Now we have got the number of moles of iron. Remember, we are looking for the mass of iron in the blade, in the razor blade. So now, the mass of iron, since we have got the number of moles of iron, how can we get the mass of iron? Remember, there is a formula again. Moles equals to mass divided by what? Relative atomic mass. Given mass, moles equals to the mass divided by relative atomic mass. So to have that's the number of moles. Therefore, to have the mass will be moles times relative atomic mass. So the mass of iron will be the moles times the relative atomic mass. So you can get it here. That's what I'm saying. I said moles. We can have moles. If you are looking for moles, concentration times volume. Concentration times volume, you can have the moles. That's what I'm saying. Okay. I get back again. The number of the mass of iron will be what? The real mass of iron in this. The real mass in this reaction will be what? Will be the number of moles of iron times the relative atomic mass of iron. We were given the relative atomic mass of iron to be 56. So the number of moles of iron times the relative atomic mass, which is 56 grams per mole. Mole will cancel per mole. We will our number of the mass of iron that we'll get will be 2.8 grams of iron. But remember, we were given the mass of a razor blade. The mass of a razor blade was what? The mass of a razor blade was a razor blade of mass 5 grams required this reaction. So the mass of razor blade was 5 grams. Now we have got the mass of iron. We have got the mass of iron to be what? We have got the mass of iron to be 2.8 grams. Now the mass of iron in the razor blade will be what? Will be 5 minus 2.8. 5, this is the mass of iron. So to have the mass of iron in the razor blade will be the difference. So we have to minus the mass of iron from the total mass of the razor blade. We will now have the one that is in the blade. So 5.0 gram minus 2.8 will give us 2.2 grams of iron. That is in this razor blade. This is the only way you can solve this problem. Make sure the equation is balanced. Secondly, use the stoichiometric equation. Use the stoichiometric equation in your calculation. If 1 mole of this required this, how many moles would that require? After having it, then you can now use the formula moles equals to given mass all over relative atomic mass. Then rearrange it, the number of moles you will get it, or the mass you will get it. After having the total mass of iron, you can now subtract it from the mass of razor blade. From there, you will now have the real mass of iron in the razor blade. Okay, thank you very much. Let's get to question number, this is 2, C2. C2. State 2 ways by which the reaction time can be reduced. This is a reaction of iron. This is a reaction between iron and dilute hydrochloric acid. In the reaction, iron 2 chloride was formed and a gas was being released, hydrogen gas. Now, this, considering the rate of reaction, we are not going to rate of reaction. How? What are the factors that can influence the rate of reaction or can affect the rate of reaction based on this? Now, state 2 ways by which the reaction time can be reduced. The reaction time, the faster the reaction, the less the reaction time. The slower the reaction, the more the reaction time. So what can we do to reduce the reaction time? What can we do to make the reaction go very fast so that the reaction time will be reduced? So state two ways by which the reaction time can be reduced. Assuming the blade retains its form at the start of the reaction. So that is C2. C2, two ways to reduce the reaction time. A reaction time. How can you reduce the reaction time? Reduce the concentration of hydrochloric acid. Reducing the concentration of hydrochloric acid would once more state two ways by which the reaction time can be reduced. I said the reaction time can be reduced. For you to reduce the reaction time, the reaction must go very fast. The faster the reaction, the less the reaction time. The reaction will take a less time to complete, to go to completion, or it will take less time for the reactants to be used up. It goes very fast. So what can we do to make this reaction go very fast? The first thing to make this reaction to go very fast is regarding the concentration. The concentration of hydrochloric acid and iron too. If we increase the concentration of hydrochloric acid, increasing the concentration of hydrochloric acid would speed up the rate of reaction. Increasing the concentration of hydrochloric acid will speed up the reaction. Decreasing the concentration of hydrochloric acid will slow the reaction and make the reaction time to go longer. Therefore, we say increase concentration of hydrochloric acid. If we increase concentration of reaction of hydrochloric acid, the reaction will go faster. Now, so the first thing is to increase the concentration of hydrochloric acid. To increase the concentration of hydrochloric acid. Increase the concentration of hydrochloric acid. To increase the concentration of hydrochloric acid. That is what you are supposed to do. Increase the concentration of hydrochloric acid. Now, increase the concentration of hydrochloric acid will lead to an increase in the reaction rate. Increasing the concentration of hydrochloric acid will increase the rate of reaction. Then, the temperature. You can also increase the temperature. Increase in the reaction temperature. If we increase the reaction temperature, increase in temperature, that will also lead to the increase in the rate of reaction. Then iron again. Using iron again. Iron is solid. Iron is solid. What can we do for iron so that the reaction, we can now grind iron to powder. We grind iron to powder by doing, grind iron to powder. That's another thing, iron to powder. Iron changed to powder. When iron is changed to powder, what happens? If iron is changed to powder, we increase the surface area of the reacting particles. Iron changed to powder. When iron is changed to powder, we increase the surface area of the reacting particles. And when there is an increase in the surface area, there is an increase in collision particles. There's an increase in the rate of reaction. So there are three factors. The first one is powder. Let me put it like that. To reduce, in a powdered form, change to powder. We can change it to powder by increasing the surface area. 2, increase concentration of hydrochloric acid. Increase concentration. Increase the concentration of hydrochloric acid. Then increase in temperature. Increase in temperature. That's all. So there are just two. There are just two. Either you change the form of the iron to powder. 2, you increase the concentration of hydrochloric acid. 3, increase the temperature. All this will lead to an increase in the rate of reaction. When the rate of reaction increases, it takes a shorter time for the reaction to get to completion. So let's go to the next question. We are done with state 2 ways by which reaction time can be reduced. Okay, D. A solid sample of sodium salt X. A solid sample of a sodium salt X does not conduct electric current. A solid sample of a sodium salt X does not conduct electric current. Give the reason for this observation. Why does a sodium salt, which is solid, why does a solid sodium salt not conduct electricity? The reason is simple. That is D1. D1, the reason is simple. Because there are no free moving ions. There are no free moving ions or electrons in the solid phase. The solid sodium salt cannot conduct electricity because 1, there are no free moving ions or electrons in the solid phase to conduct the electric current. First of all, the major thing that will result, what should come to your brain now will be the 2 things that will cause the conductivity of electricity or electric current are ions, mobile ions, ions that are mobile, free moving ions. They will lead to the conductivity of electricity. Then again, electrons. Electron will also lead to the conductivity of electric current. So that's why we say that the solid sodium salt cannot conduct electricity. The reason is because there are no free moving ions or electrons in the solid phase to conduct the electric current. Let's go to D2. D2. Give two ways by which X, that is sodium salt, a solid, that is a solid sodium salt. Give two ways by which X can be made to conduct electricity. Two ways by which a solid sodium salt can be made to conduct electricity. Okay, there are two ways that you can make it to conduct electricity. Going back to our knowledge of electrolysis, our knowledge of electrolysis, solid salts can only be made to conduct electricity by dissolving them. When they are dissolved in solution, the ions are being broken down. When they are dissolved, the ions are being broken down and are now freely moving and aid in the in conducting electricity. So we can now say that sodium salt X will only conduct electricity when in a molten state or in aqueous solution. Sodium salt X will only conduct electricity when in a molten state or in an aqueous solution. Because in a molten state, at least the ions can now move to conduct electricity, conduct current. In the aqueous solution, the ions are freely moving and they can conduct electricity. So now, let's go to D3. If sodium salt X gave a greenish yellow gas, if X gave a greenish yellow gas Y on warming with manganese 4 oxide and concentrated sulfuric acid, identify X and Y. A sodium salt gave a greenish yellow gas Y when it was reacted with manganese oxide and concentrated sulfuric acid. Remember, what is a greenish yellow gas? A greenish yellow gas is chlorine. Chlorine gas is a greenish yellow gas. So what you should begin to picture what X and Y are going to look like. A greenish yellow gas is a chlorine gas. So you should be able to have the other answer for X. This is the answer for you. X is sodium chloride and Y is chlorine gas. Finish. X is sodium chloride. That is a sodium, that is a solid salt of sodium. X is sodium chloride and Y is a chlorine gas. And this is the equation. Look at the equation here. Look at the equation here. This is sodium chloride when reacting with manganese 4 oxide and concentrated sulfuric acid. It gave what? Manganese sulfate plus sodium sulfate, water, and chlorine. That is the equation to show you this is X is sodium chloride. But do not give this equation. This is for revision purpose. For the purpose of revision, that's why I have given you this equation. So X is sodium chloride and Y is chlorine gas. So we now move to the next chlorine gas. So once more, a question like question number 1, you are supposed to have a detailed knowledge of transition metals. You are supposed to have a detailed knowledge of transition metals. The different characteristics of transition metals. That's why I gave you all to 6. Transition metals are different from D block elements. Even though they are all they are different. Even though they are also found in the D block, but they have characteristics that are unique only to them. Okay. Then question like question B that had to do with bronze, alloys, constituent elements, and the major uses. You should be able to know the composition of each alloy: bronze, steel, duralumin. Then a complicated question which you were most students are usually confused as stoichiometry, involving calculations. In this one, like a C part of it, you have to make use of your equation. You have to make use all the data that have been given here: 5 grams of razor blade, 50 cm cube of 50 cm cube of 2 molar hydrochloric acid are very, very important. It's always good for you to make use of it. Okay, thank you. Once more, for those of you who haven't subscribed to our channel, please like the video, share to other learners, and create time and subscribe to our channel so that you have all the solutions to these past questions. We are going now to question number 2. We are going now to question number 2. Question number 2, it has to do with the ionization energy and the rest. Explain what is meant by ionization energy and state how it varies across a period in the periodic table. Remember, ionization energy. What is ionization energy? Ionization energy is especially the first ionization energy. Energy required to remove the first electron. Then generally we can say ionization energy is the energy required or needed to remove electron from 1 mole of gaseous atom, forming 1 mole of gaseous ion with a unipositive charge. So, as I said, the first ionization energy, IE, is the energy required to remove 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion with a unipositive charge. Fellow learners, I want you to use this equation so that in an examination room, you may not be able to remember how to put it. If you write this equation like this: a gaseous atom, this is 1 mole of gaseous atom forming 1 mole of gaseous ion, and this is an electron that has been removed. If you can remember this equation, you are done. I said it is energy required to remove 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion with a unipositive charge. That is what we call ionization energy. Then they said explain how it varies across a period in the periodic table. Okay, the period in the periodic table. Periods are from left to right of the periodic table. As you move, elements are arranged in the periodic table with according to increasing proton number. As you go across from left to right on the periodic table, what happens? The elements are increasing in, there is an increase in the number of protons. They are arranged in an order of increasing proton number. With increasing proton number, what happens? Across the period of the periodic table, there is an increase in the nuclear charge. As you go across from left to right of the periodic table, there is a general increase in the nuclear charge. As the nuclear charge increases, there is also a decrease in the atomic radius. What happens? This decrease in the atomic radius causes the outer electron or the outermost electron to be more attracted to or to be more attracted to the nucleus. The force of attraction between the outer electron and the nucleus becomes stronger and stronger as you move across the period. For this reason, it will require a high energy to overcome that force of attraction. So therefore, we can now say, as you move across the period, from left to right of the periodic table, there is a general increase in the ionization, in the first ionization energy. There is a general increase in the first ionization energy because of increasing nuclear charge, which is as a result of increasing or decreasing distance of the outermost electron from the nucleus. So this is a sample write-up I prepared for you. There is a general increase in the first ionization energy across a period of the periodic table because the increasing nuclear charge resulting from increasing proton number and decreasing atomic radius makes the attractive force between the nucleus and the outer electrons greater and will require more energy to overcome it. Finish. If you put it like that, you have all your marks. So there is a general increase in the ionization energy across the period. Let's go to this is A1. A2 will be we have given what is ionization energy, and we have given why there is how it varies across the period, that there is a general increase. Now we go to A2. If the electronic configuration of an ion, Q2 plus is 1s2, 2s2, and 2p6, give 1 the atomic number of the atomic number of Q, 2 the formula of the chloride of Q, and 3 reason why Q is described as an S block element. That's good. So we go to A2. The atomic number for Q here, based on this information here. Based on the information here, remember 1s2, 2s2, and 2s2 and 2p6. This makes a total of what? 10 electrons. But here, Q2 plus or Q ion indicates that 2 electrons have been lost. If 2 electrons have been lost, and now the electronic configuration is only 10 electrons, the 2 electrons that were lost plus the two electrons that were lost plus the 10 electrons will give us what? Will give us 12, a total of 12 electrons. Now, this is just an ion of Q. This is just an ion of Q. In the normal state, this is an ion of Q. This is a cation, or this is a cation, an ion of Q. The normal state of Q will be what? The normal state of Q will have how many electrons? It will have 10 electrons plus these 2 that were lost, making a total of 12 electrons. And remember, we said atomic number is equal to the number of protons, and the number of protons is equal to the number of electrons. So if atomic number is 12, if the number of electrons are 12, then the atomic number is 12. So the atomic number for Q is 12. So atomic number for Q is 12. Now, let's go to the next one. 2. Formula of the chloride of Q. The formula of a chloride is a group 2 element. Is a group 2 element. A group 2 element. This is a group 2 element. It will have what? It will be Cl2. Let me say, for example, Q is magnesium. So magnesium chloride will be MgCl2. But we are not using magnesium, we are using Q. So it will be QCl2. So the formula for chloride of Q is QCl2. Then 3. The third one is reason why Q is described as an S block element. Very good. Why is Q described as an S block element? If you look at the electronic configuration that we're given, now 1s2, since Q has atomic number of 12, I don't mean the ion, has atomic number of 12. The normal electronic configuration or electron configuration, the normal electron configuration for Q will be 1s2, 2s2, 2p6, and 3s2. It will be 3s2. It means that the last electron of Q are found in the s orbital. The last electron of Q are found in the s orbital. So the answer I have given you here is that the last outermost electron in Q are found in the s orbital. If we use atomic number of 12 and want to write the electron configuration, you will see that the last two electrons are found in the s orbital. That's why we say they are. That's why we say that Q. That's why we say that Q is described as an S block element. Okay. Now 2b. 2b is explain why isotopes have different mass numbers. Explain why isotopes have different mass numbers but are chemically alike. What are isotopes? Isotopes are atoms of the same element having the same atomic number but different mass numbers. What is causing the difference in the mass number of the same isotope? Let me say chlorine 35 and chlorine 37. What is causing the difference? The difference between the mass number, the difference in the mass number is as a result of the difference in the number of the number of neutrons. It's the number of neutrons that is causing this difference. So let's go back to our question. They say explain why isotopes have different mass numbers but are chemically alike. That's good. Now, the answer I have for you is this. Isotopes of the same element have different mass numbers, because of the difference in the number of neutrons. That's just all. The difference in the number of neutrons. But are chemically alike. They are chemically alike because neutrons are neutral. Neutrons are neutral and are not involved in chemical reactions. That's just finished. Neutrons do not take part in chemical reaction. They may have different mass numbers, but despite the fact that they have different mass numbers, but they undergo the same reaction. The reaction is the same for all of them, all the isotopes. Because neutrons are neutral and are not involved in chemical reactions. Okay, let's proceed to questions, the second part of it. Calculate the relative atomic mass of an element arrow, given that the relative abundance of arrow is 6329 and the other isotope is 2965, and the relative abundance are 68% and 32% respectively. Calculate the relative atomic mass of arrow. Okay, fellow learners, this is how you can calculate the relative atomic mass of any element given the isotopic masses and their relative abundance. The relative atomic mass is a summation of the relative atomic mass, a summation of the relative isotopic mass times the relative abundance divided by summation of the relative abundance. For instance, here we had the isotope 63 of mass number 63 had the relative abundance of 68. What we need to do is 63, the relative abundance, times the isotopic mass plus the other one that has the other one, which is 68, the isotope of 65 that had the relative abundance of 32, 65 and 32. So it will be 65 times 32, then sum of percentages, because their percentages are the abundance. So the total sum of the abundance will be 68 plus 32. If we do all this, it will be 100. So the total summation of the relative isotopic mass times the relative abundance will give us 6,364 divided by 100, which is the sum of percentage. And the relative atomic mass will be what? It will be 63.64 atomic mass units. AMU is atomic mass unit. That is the unit given to relative atomic masses. Okay, 2C1. List 2 uses of chlorine. What are the uses of chlorine? There are 2 uses, but I've given you 3. Chlorine is used for the treatment of water. Treatment of water, that is, disinfect water or disinfect sewage and industrial wastes. We can use chlorine for the treatment of water, that is drinking water, disinfect water. In a treatment plant, chlorine is always used to disinfect the water, that is to kill microorganisms in the water. It is also used to disinfect sewage before you dispose the sewage into maybe rivers or oceans or lake. You have to disinfect the sewage and industrial wastes. 2, chlorine is used as a bleaching agent in paper and in cloth making. 3, chlorine is used as a disinfectant in cleaning. Most cleaning industries or companies, they will use chlorine as a disinfectant when in their cleanups. Okay, let's proceed to 2C2. 2C2 is about give the balanced half equations. Balanced half equations for the following. You will have chlorine gas plus the bromide to give the chloride and the bromine gas. I don't know why bromine gas is liquid. Well, it is bromine is usually as liquid, but the one given here, yeah, no problem. It's okay. Now, the half equations are supposed to be, because here, if you look at this equation, chlorine here is 0, and the chlorine here is minus. So there's reduction taking place in chlorine. So chlorine will undergo reduction. Chlorine will undergo reduction. Now, bromide. You see that the bromide is -1. Now here is 0. From -1 to 0, we will know that from -1 to 0, bromine is undergoing oxidation. So bromine will undergo oxidation. So the half equation they are talking of, because this is a redox equation, they are talking of reduction equation and oxidation equation. So this is what I have for you. For oxidation, bromine, we have the bromide that will lead to the bromide, which is liquid, 2 ions, and then reduction will have the chlorine that is being reduced to the chloride. This is the equation. This one will lose electron. These electrons are gained. This one will lose electron and is oxidized. Then the electron are gained by the chlorine, and when it gains electron, it is reduced. So this is oxidation equation, and this is oxidation half equation, and this is reduction half equation. Secondly, again, for the purpose of revision, chlorine is a stronger oxidizing agent than bromine. It is higher of the group 7, more than bromine, and it is more reactive than bromine. For that reason, it will displace bromine in any chemical reaction. Okay, let's proceed. Let's proceed to the next question. State, given the following substances, we have tetrachloromethane, which is liquid. We have copper 2 chloride, which is solid. We have hydrogen chloride gas, and we have potassium chloride in aqueous solution. Now, state which of them has the highest entropy value. 2. State which of them contains chloride ions. 3. State which of them can be decomposed by an electric current. Okay, let's go to entropy. If you look at this compound like this, it should be remembered that gaseous substances have the highest entropy. Gaseous substances have the highest entropy, more than liquid and more than solids. For that purpose, hydrogen chloride gas will have the highest entropy value. Contain chloride ions. Of course, chloride ions, you can notice that a substance contains ions when it is in aqueous solution, when the ions are freely moving. When something dissolves, that is when the ions are released. So it will contain this one. Copper 2 chloride would have contained this thing, but it is in a solid state. In a solid state, the ions are not there. The ions are only found in a substance that is in an aqueous state. So for that purpose, the substance that will contain chloride ions is potassium chloride, aqueous potassium chloride. And lastly, give the full state the substance that can be decomposed by an electric current. Let's go back to your knowledge of electrolysis or electrochemistry. Current, when a substance is dissolved in solution, and a current is passed into it, the current will help to break down the substance. This is not in solution, but carbon tetrachloride is not. Carbon tetrachloride, or what we call tetrachloromethane, or carbon tetrachloride, it is liquid. So it cannot be decomposed by an electric current. A copper 2 chloride, it is solid. It can't happen. Hydrogen chloride gas is gaseous. It can't happen. But potassium chloride is in aqueous solution. This is an electrolyte. Automatically, being in aqueous solution shows that it is an electrolyte. And for that purpose, it can be decomposed by an electric current. And we can now say that the substance that can be decomposed by the electric current is potassium chloride or aqueous potassium chloride. These are the 3 answers for the 3 questions. So we have hydrogen chloride, we have potassium chloride aqueous, and we have potassium chloride aqueous. For the purpose of revision, fellow learners, substances in aqueous state have the highest entropy than those in the solid and liquid state. Then above all, entropy will also increase with increase in molecular weight. This is only for your revision purpose. Let's go to D1. D1 is D1. You have a chemical reaction here. Hydrogen sulfide, which is a gas, plus a cation here. Yes, an ion here. Aqueous, this is a metal. Aqueous a metal that is in solution. It is in equilibrium. This is an equilibrium condition to form MS, which is solid, and 2 hydrogen ions that are being released in solution. This reaction is exothermic because the enthalpy change here is enthalpy or energy change, or enthalpy change here is negative. For that purpose, it is an exothermic reaction. The question reads, state and explain the effect of each of the following on the equilibrium position. On this position here. 1. Remember that it is an exothermic reaction. Now, the effect of the following. Increase in temperature. Increase in temperature. Increasing a temperature of an exothermic reaction, the equilibrium will shift but to the left. Equilibrium will shift to the endothermic direction, leading to what? Leading to the production of more hydrogen sulfide and M2 plus. Then addition of solution of M and O. This is an increase in the concentration. Increasing the concentration of this, that is addition of the solution of this, will mean that we are increasing the concentration. Of M2 plus. An increase in this concentration will lead to what? Will lead to an increase in, will shift the equilibrium to the right, and leading to the will shift the equilibrium to the right, leading to the production of more MS and hydrogen ions. An addition of acidified potassium manganate. So now I have these answers for you here. Okay, I have these answers for you. I said in the first case, equilibrium will shift to the left in the endothermic direction to reduce the temperature, hence producing more of hydrogen sulfide and the M2 plus. Now, on the concentration, equilibrium will shift to the right and the concentration of the product increases. Then the last one, equilibrium shift to the left. Equilibrium will shift to the left, thus the concentration of reactant increases. That is just all I have. So once more, for those of you who haven't subscribed to this channel, please like the video, share to other learners, and create time to subscribe to this channel. Thank you for listening. It's a pleasure having you today.